Got a good Thursday cooked up here. What's up, man? Okay. So, last time we talked about matrix multiplication and the process that goes through that. Like you mentioned last time, it's pretty tedious. Right? It's not the most fun thing in the world. But alas, here we are. So first thing is just to check to see if we can actually do matrix multiplication based on the sizes of the matrices. So this is a 2 by 3 matrix because there's 2 rows and 3 columns. This is a 3 by 2 matrix because there's 3 rows and 2 columns. And so the important part about this is that these two numbers are the same, because if they're not the same, then we wouldn't be allowed to do matrix multiplication. It wouldn't work. Okay, but this is nice. So we start off by going on the first row with the first column. So 2 times negative 2, negative 4, plus negative 3 times 0, which is 0, plus 1 times 5, which is 5. Okay, so there's the first entry of my matrix. Now, I shouldn't erase that first one. All right, so we stick with the first row, but then we move over to the next column. So 2 times negative 4, negative 8, plus negative 3 times negative 1, so that's positive 3, plus 1 times 1, which is 1. All right, now we can get rid. All right, we used this first row with both of these columns, so now let's move down to use the second row. And we'll first use it with the first column. That was a really great line. Right. 1 times negative 2, negative 2, plus 4 times 0, 0, plus negative 7 times 5, so that's minus 35. And then lastly, second row with the second column. 1 times negative 4 is negative 4. 4 times negative 1, also negative 4, so minus 4. Negative 7 times 1, negative 7, so minus 7. And all of this is inside of a nice matrix here. So now it's just actually doing those last calculations. Negative 4 plus 0 plus 5 is 1. Negative 8 plus 3 plus 1, negative 4. Negative 2 plus 0 minus 35, minus 37. Negative 4 minus 7, negative 15. And there's my final answer. I note that this is a 2 by 2 matrix, which makes sense because, remember, our final matrix will always end up being those two outer numbers. So the two outer numbers are 2 and 2. So that means the answer we get from matrix multiplication should be a 2 by 2. Wow, that's hard to read. Okay. Just box it. That's kind of fun. 2 by 2 matrix. Remember, when the amount of rows and columns is the same, we call it a square matrix. So this is a 2 by 2 square matrix. Okay. All right. Not difficult in terms of the calculations you have to do, but just kind of difficult because there's a lot of numbers to keep track of. A lot of multiplication and addition and stuff. All right, so we're going to go on today to talking about different types of what are called row operations. So operations that we can do not on an entire matrix, but on the rows specifically of a matrix, and how we can notate that and do some different things with it. All right, so first off, we can interchange rows. So that just means we switch the places of any two rows that we want. This does not change any of the values. So it's literally just you take this row, now it's down here, and now this row's up here. You just switch the places of any two rows. Right. The notation that we'll use, for example, would be like this, except not a diagonal line like that. Let's try more of a straight line. Okay, so for example, something like this, which tells me to switch rows 1 and 2. All right, I would just trade places. Okay, so for example, let's do, if I have this matrix down here, let's say we want to, or let me put some space. Let's swap row 2 with row 3. Why not? Okay. So that means row 1 is just staying exactly the same. -2, -4. Nothing to mess with there. But row 2 is now going to be row 3. Row 3 is going to be now row 2. Right, row 2 gets moved down to row 3. Right, and that's it. Okay, that's all it is. It's just switch the rows. Pretty easy. Very important to know the notation because we need to use the notation explicitly to describe what we're doing in each step, because we're going to have multiple different row operations, so we need to keep track of what we're using. Okay. Next step is called scalar row multiplication. So scalar multiplication for matrices was just multiply everything in the matrix by a number. So that's sort of similar, except now it's just multiply every row, or sorry, multiply everything in the row multiplied by some scalar, some number. Okay, now also we can think about, well, what if we want to divide, right? Maybe I don't, depending on what we're doing, we'll have certain goals in mind. Maybe I don't want to multiply to get some number. Maybe I want to divide some number. Well, that's fine. Remember that division is just the same thing as multiplying by a fraction. The notation that we'll use is just, so we'll just have the row, whatever it is, like say row 3, and say we want to multiply that by -2. Then we'll just put -2 row 3. Right? That's it. Right? So down here, again, it's that same matrix that I had before. So I'm just going to keep using that one over and over again. So let's say I really want to multiply row 1 by 5. And so I'll put an arrow here just to say that I'm going from left to right. So 5 times row 1. So -2 times 5 is -10. -4 times 5, or sorry, wait. -2 times 5 would be +10. Negative 4 times 5. No, wait. Not negative 5. What am I doing? I had positive 5, but thought I had negative 5. And then when I had negative 5, I actually had positive 5. Okay, 5 times 2 is negative 10. 5 times negative 4 is negative 20. And then these other two rows, so this tells me only change row 1. So row 2 and 3 stay exactly the same. Right? This stuff is just exactly how it was. 0, negative 1, 5, 1. No change. Okay. So that's my second row operation. Again, pretty easy. Just take a row, multiply it by whatever it says. No problem. All right, this is the one that gets a little trickier. Add multiples of one row to another row. All right, so this doesn't have a catchy name. This basically, the name here just describes exactly what it does. Adding multiples of one row to another row. And the notation will look like this. Let's say. Okay. Maybe something like 2 times row 4 plus row 1. Okay, so in this notation, there's a couple very important things to note. Whatever you see here in this first row, this row will not change. Okay, now I know that's kind of confusing because we're saying, well, aren't we multiplying it by 2? Well, we're using this row in our calculation, but at the end of the day, we're not actually changing this row. Right? This row, the second row that's listed, this is what will change. Okay, this is where the actual operations are happening that I can see changing in my matrix. Okay. So let's try a couple of these because these are a little trickier. So let's say 2 times row 1 plus row 3. Okay, so remember, this first row that's listed, right? Doesn't matter which row it is, row 1, row 2, row 3, or like in the example I use row 4. But this one is not changing. Right? I'm using it as part of my calculations, but it is not changing. So row 1 is not actually changing. I'm just going to leave that as is. Negative 2, negative 4. Stays exactly the same. Okay, now also notice in here that row 2, nothing in this operation says anything about row 2. So that means row 2 is also just staying the same. Right? But as we can see then, the second row that's listed is the one that is changing. So this row is changing. Row 3 is the one that's going to change. So here's what we do. We match up our values. So first off, we have 2 times row 1. So we're going to look at the component. So like when I look here down at 5, what should go here? I'm going to look up above it to row 1. And I'm going to multiply that number by 2. So 2 times negative 2 is negative 4. So then negative 4 plus the row 3, so negative 4 plus 5 is 1. So again, I'll write out explicitly. The way that I got that is negative 2, well, I put to 2 first to keep it consistent. Oh my gosh, come on. 2 times negative 2 plus 5, right? That's where that 1 came from, which is this 2 is this times negative 2, which comes from the first row, and then added to the third row, which is 5. Okay, now same thing over here. So now looking at my next spot, so I'm going to go up to row 1, so negative 4, multiply it by 2. So 2 times negative 4 plus row 3, which that spot is 1. So 2 times negative 4 is negative 8. Negative 8 plus 1, negative 7. Row 1 did not change. Row 2 did not change. It's only row 3 that is actually changing. All right, let's look at another example. Again, it's pretty weird. So let's say from this matrix we want to let's say negative 3 row 2 plus row 1. Okay. Remember, this one will not change. Okay. Always write whatever the row is that you want to change, that should be the second row here. Right, in the second spot, I guess. So row 2 is not changing. So I'm just going to write, I'm going to copy down row 2 exactly how it was. 3, negative 1, 6. This first row, however, is changing. So negative 3 times row 2 plus row 1. So I'm just going to go one spot at a time. So first I'll look here. Right, so negative 3 times 3. Right, so negative 3 times 3 plus the first row, so that's plus 2. Negative 9 plus 2, negative 7. Right, so now I'll move over to the next spot. Negative 3 times row 2, which this is now negative 1, plus row 1, 4. So that's 3 plus 4, positive 7. And then I move over to my final spot. Negative 3 times row 2, which this spot is 6, plus row 1, which is negative 5. So negative 18 minus 5, negative 23. Oops, you can, it's a little bit cut off. There we go. Okay, so that's how that third row operation works. Right? Is we take multiples of one, add it to the other. So those are the three operations: interchange rows, multiply an entire row by a scalar, or add multiples of one row to another. So now let's start. We're going to use these all together. Okay, so perform the indicated row operations on the matrix in the indicated order. All right, so I have my starting matrix, and I also have a list of row operations that I want to use, and then it tells me use them in this specific order. So this is the first thing I do, this is the second thing I do, this is the third thing I do. Okay, so let's do that. So first up, I'm swapping row 1 and row 3. So 3, 5 and negative 2, 4 are switching places. So negative 2, 4 is up top. That middle row stays the same. And now the third row is 3, 5. And just from that switch. Okay, so I got that one down. You can cross it off if you want. I don't know. Next row operation, 4 times row 3. Okay. So 4 times row 3. Again, make sure we do want to write out this middle step that tells us what we're doing. So 4 times row 3, so that means first off, row 1 and row 2 are staying the same for right now. I'm only changing row 3 at the moment. So 4 times 3, 12. 4 times 5, 20. Right. Did that one. And lastly, row 2 plus row 1. Okay, remember, whatever is in this spot, in this notation, this spot row does not change. I know I'm going to keep saying that 1,000 times, but students still always end up changing it. Okay, row 2 plus row 1. So I'm looking at the second row and multiplying it by 2. So 1 times 2 is 2. 2 plus negative 2 is 0. 0 times 2 is 0. 0 plus 4 is 4. All right, so that's my new row 1. I knew that row 1 was going to change because this notation, the way it's set up, whatever's in this spot is what's changing. All right, but row 2 stays the same. So row 2 was 1, 0, so it stays 1, 0. And row 3 is not listed anywhere here. It doesn't have anything to do with this operation, so row 3 also stays the same. Boom. Okay, so we did all 3 row operations in the specific order. I think when you take the PFA, it'll ask you questions like this, but then it won't. The answers won't just be like which matrix is it. The answer will be like for the final. After you do the row operations, what is this entry of the final matrix that you get? So remember, A22, what does this notation mean? This means the entry that's in the second row and the second column. So second row, second column. So that's 0. So what happened? So A22 equals 0. That's the answer you would put in. Okay, that's just the way it is on the PFA, I'm pretty sure, is that it asks you to do all the row operations, but instead of asking just for the final matrix in general, it just asks for a certain specific spot. So you still have to do the operations, but then it'll ask you just for one of these. So remember the numbers, the first number here, this first 2 means what row, this second number means what column. So second row, second column. That means 0 is our answer. Okay, let's try another one. Perform the indicated row operations in the indicated order. Great. So, first up, swap row 1 and row 3. Great. So, my new row 1 is 4, 4, 4, negative 8. Row 2 has nothing to do with this operation, so row 2 stays exactly how it was. And row 3, so after my swap, my row 3 is now 5, 2, 1, 0. Boom. Got that one done. So now my second row operation, 1/4 times row 1. Again, if I'm multiplying by a fraction, that's the same thing as dividing, right? So multiply by 1/4, I'm just dividing by 4. That's another way to think about it for row 1. So 4 divided by 4, 1. 4 divided by 4, 1. 4 divided by 4, 1. Negative 8 divided by 4, negative 2. This operation has nothing to do with row 2 and row 3, so row 2 and 3 stay exactly the same for now. Okay, boom, did that one. And so my last row operation is adding multiples of one to another. Okay, so a little trickier, but just have to be careful. So negative 5 row 1 plus row 3. Okay, so row 1, since it's in this spot in the notation, row 1 will not change. So I'm just going to go ahead and copy down row 1 because I know it's not changing. Same thing with row 2. Row 2 has nothing to do with this operation, so it will stay exactly how it was before as well. Okay, but now row 3 will change, right? Whatever's in this second spot will change. So I'm going to take my first row, multiply those values by negative 5, and then add them to what we had in the third row. Okay, so let's just start here. So 1 times negative 5 is negative 5. Negative 5 plus 5 is 0. That's actually interesting. We're just practicing using the operations now. When we do this for our what we're actually going to use these problems in, we're not just learning how to do this for no reason, just for but when we actually use these in problems, we're going to want 0 a lot. So that'll be a lot of our decision making is how do I know which number to multiply by which row to add to whatever. A lot of times it's to get our goal of we're trying to make something 0. Right? So, but right now we're just practicing, so these won't all be 0. Next spot, 1 times negative 5, negative 5. Negative 5 plus 2, 3. No, sorry. Negative 5 plus 2, negative 3. Okay. Negative 5, next spot, negative 5 times 1 is negative 5. Negative 5 plus 1, negative 4. And then last spot, negative 2 times negative 5 is positive 10. Positive 10 plus 0 is positive 10. And again, on the PFA, the answer choices won't just be a full matrix like this. Instead, maybe it looks like where it asks you, hey, what's A32? Well, 32 means the first number means the row, so third row. The second number means the column, so second column. So this answer right here, negative 3. That's what A32 is. Or maybe it asks for a A24. Okay, well, wait a minute. Yeah. 2 means the second row. 4 means the fourth column. 1, 2, 3, 4. So that must mean it's asking for 2. All right, so it just depends. This question is just, random. It's just me asking you one of those values. Okay, so it just depends on what it asks for. I think that's it. Yeah. So just practicing using the row operations. Hopefully we're going to get good at these because I think next time, let me check. Yes, next time we have some doozies ahead of us here.